Exercise related to the Doppler's effect, first 17 I have already recorded, so we'll begin with question 18. In question 18, a scientist arranged apparatus to test the Doppler's effect. He arranged the trumpeters to play a note of one frequency on a moving train. Stationary musicians standing by the track listened as the train went past and compared what they heard with the original note. How the sound travel to air. The first one is actually the propagation of the sound. So how a sound wave travel. So sound wave travel by vibration of the particle parallel to the direction of the wave by compressions and the rarefactions. The first part is just we have to explain it, the propagation of the sound wave. Sound wave is longitudinal. And mechanical requires, which means it requires a medium to travel. It propagate by vibration of the particles parallel to direction of wave, produce series of compressions and rarefaction. So sound is a longitudinal and a mechanical. Longitudinal means the particle vibrate parallel. So sound wave is a longitudinal and mechanical, and it propagates by vibration of the particles parallel to direction of the wave by produce series of compressions and rarefactions. The next part is describe and explain uh, what the stationary musician would hear as a train traveled towards them and then away from them. Yes, anyone want to answer this? So there's a train which is producing a one note, like a one frequency, and the musicians are there, like it's producing one frequency, and the musicians are observing the frequency observed from the train. The question is, like, let's say the musicians are here. So the question is, what happened as the train approach, like move towards them and then away from them? So what we'll observe? So if the train is moving towards the musicians, the frequency observed will be higher, and if the train is moving away from the observer, the frequency will appear to be lower or frequency decreases. And the speed of the wave is not changing because look, if it is producing a sound wave, if this says 330 meter per second, the sound wave speed does not change. So we have the formula speed is frequency times the wavelength. So if the speed is not changing, what is the relation between the wavelength and the frequency? They are inversely proportional. If the speed is not changing, so if the frequency appear to be longer, then the wavelength appear to be shorter. So how we structure this answer? The frequency observed by the musicians when as the train move towards appear to be higher and the wavelength appear to be shorter. And opposite will happen. And opposite will happen if the frequency it's moving away, then the frequency appear to be shorter and the wavelength appear to be longer. And we have to say one point as well, the speed of the wave does not change. Is it clear, this one?
Yes, sir.
Okay, the next one. Some cars have reverse sensors to aid parking. Maybe you have observed, like example, when the car in parking, they have the sensors are there, rear and the forward sensors. So when the car is reversing, a transducer on the rear of the car emits a pulse of ultrasound. So, example, if this is representing a car, the rear transducer is emitting an ultrasound. Ultrasound means like it's not in audible range higher than 20,000 hertz. We call that as an ultrasound. The pulse are reflected by the nearby object. So let's say there's a nearby object is there, and the pulse is reflected from the nearby object. If an object is detected close to a car, an alarm sound and produce to warn a driver. Like if the object is too close, then it will detect, like the alarm will or the beep is there, which warns the driver. Determine whether a pulse of a duration. Look, can I use a pulse with a duration 4 seconds suitable to detect a distance 10 centimeter, like behind the car. So see here, it's the same thing. One of the student was asking in a chat, like if we don't know the distance and how we know which pulse is suitable. So if they will provide you, like there's an object which is 10 centimeter from us. So 10 centimeter from us means in terms of the meter, we divide by 100. So it is equals to 0.1 meter, 10 centimeter or 0.1 meter. The pulse duration, like for how long it is produced, it's produced for 5 exponent minus 4 second, and it is producing, it's a ultrasound, so sound wave is there. It's like it is producing an ultrasound as they mentioned. So it's the speed of the sound wave. So what is the length of the pulse it is producing? How we can determine the length of the pulse? That is speed multiplied by time. So speed of the wave is 300 and like the length of the pulse which you are producing, speed and time. Speed is how much? That is 330. And for what duration it is produced? It is produced for 5 into 10 power minus 4. So what is the length of the pulse produced here? When you multiply them, you will get 0.16. So you got 0.165 meter. And we want to determine that 0.1 meter. Is it suitable?
No.
No,
And why it is not?
because it is shorter.
Longer.
Yeah, like the length of the pulse. The length of the pulse is greater than the distance we want to record. Or suitability, you can also compare the time interval as well, but this is a total, remember, this is a total length of the pulse. It's given in the question. The duration of the pulse. Duration of the pulse means like it goes and come back. That is the total duration of the pulse. So 5 exponent minus 4 is the total. You got my point? It's not the total to time to reach the object. It's the time to go and come back. So what will be, this is a total one. But what will be the time to only go, travel? So it will be 5 into 10 to the power minus 4 divided by 2. So means this total will be divided by 2 when this total is divided by 2. So what is the answer? The answer 0.165 divided by 0.165 divided by 2. So what we got? We got 0.083. So 0.083 is the length of the pulse. You got my point? The length of the pulse. So the length, actual length of the pulse, because to go and come back, the duration of the pulse is given. And this is not the duration for which the pulse is produced. In the question they mentioned, determine whether a pulse duration. So this is a duration of the pulse. So the duration of the pulse was 5 into 10 to the power minus 4 seconds. Would be suitable to detect an object which is close as 10 centimeter. So 5 exponent minus 4 is the duration of the pulse, means the pulse is going and then it is coming back. That total duration is 5 into 10 to the power minus 4 seconds. And the duration to go, like the time to travel, will be half of this. Like that will be 2.5 into 10 to the power minus 4. So the 2.5 into 10 to the power minus 4 second is the time to travel and the speed of the pulse is there. So the distance, the length of the pulse which we are producing is 0.083. And we want to determine a distance of 0.1 meter. So mean this is suitable. Is it clear, this one?
Yes, sir.
Why we divided by 2? Because in the question, they give us the duration of the pulse. Pulse of duration. Duration of a pulse means that the pulse is going and then coming back in this time interval. Or you can also solve this question in another way, like in comparing a time. So you can simply compare the time. If the object is, like example, 10 centimeter from the car and 10 centimeter or 0.1 meter. So what is the, like, for this like 0.1 is there. So we have the, if I want to determine how much time I need to detect that, like, because like we should send the duration is there for this total. So speed is equals to 2d divided by t. If I send the pulse and the pulse bounce back, so how much time the pulse should take? So the time the pulse should take 2 into d divided by s. So 2 multiplied by distance will be 0.1 and divided by speed, which is 330. What is the time interval when you simplify this? 2 into 0.1 divided by 330. So
6
means
into 10 power minus 4.
So 6 into 10 to the power minus 4 seconds. So means the pulse will take 6 in, like the radiation will go and come back in 6 exponent minus 4 second. And we are using a shorter than that. So if we are using a shorter than that, that definitely the one which is going and coming back will not interfere with each other. If this time interval, let's say this time interval was, instead of 5 exponent minus 4, they give us 20 into 10 to the power minus 4. So this, the duration, the time for the pulse is longer than the time it has to take to bounce and come back. So then it won't be suitable. So either you can compare the time, or either you can compare the distance between the source and the observer, and the length of the pulse. Is it clear?
Yes, sir. Yes.
Then we have
हो गई सबसे
the next is explain why the reversing sensor would not work if it is used audible sound rather than the ultrasound. Like usually what happens when we use the audible sound, the sound which we can hear, audible sound is usually have like ultrasound is higher frequency or a shorter. If we compare, we have the formula speed is distance, speed is frequency times the wavelength. The ultrasound is having a high frequency and a shorter wavelength. But the sound, the normal sound will have a, audible sound will have a lower frequency and a longer wavelength. So as a result, when it is having a longer wavelength or the sound waves have a longer wavelength means like it will also have a longer time period. So when it will have a longer time period, it will take like the pulse to complete one wave, it will take longer time to complete that. So we won't be able to detect, or like ultrasound has a shorter wavelength, or we can also say sound waves have a longer wavelength opposite. And if it is having a longer wavelength means it will have a greater time period or take a longer time. So whenever we want to determine a shorter distance, we prefer a smaller wavelength or a smaller, like the waves with a shorter time period. So why audible will not work rather than the ultrasound? So the audible will have a shorter frequency or a longer wavelength, where ultrasound is having a higher frequency or a shorter wavelength. So the length of the duration of the wave is shorter, but in normal sound, the length or duration of the wave is longer. Transducer means a device which can convert one form of energy to another. We call that as a transducer. So shorter the wavelength, more detail we will get. And here why it won't work in this case, because as you can see, the reflecting surface is having an angle. So when the sense is producing the radiation, it bounces back. It is not reflected back to the car. So it won't be able to detect the radiation. So suggests why a sensor may not detect a sloping object because the reflected radiations are not reflected back to the car. Is it clear, this one?